Welcome and thank you for joining us today for How to Understand Network Dependencies, Best Practices for Automation and Limiting Risk. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speaker is Enterprise Management Associates VP of Research, Jim Fry. Jim has over 25 years of experience in the computing industry, developing, deploying, managing, and marketing software and hardware products, with the last 20 of those years spent in network management. At EMA, Jim is responsible for the network management practice area. And before I go ahead and turn things over to Jim, I did want today's audience to know that Jim will be concluding his presentation by taking your questions. So I do encourage you to log those at any time throughout the course of the presentation by using the Q&A functionality located in the right-hand column of your screen. Also, today's event is being recorded, and you will receive an email from EMA tomorrow that will include the on-demand playback as well as some additional resources. So be on the lookout for that email. And now I'd like to go ahead and turn things over to our featured speaker, Jim Fry. Jim?
Thank you, Raleigh, and welcome everyone. Thanks for joining us. I think we have an interesting topic today. We're going to talk about network dependencies, and here's sort of the way we're going to go about that. This is not necessarily a well-known term, so I'm going to spend a little time talking about what we mean by network dependencies and why they're important. Then we'll talk about where we can find this information. And then we'll spend, I think, the second really half and the bulk of the time on some best practices around how to leverage automation in respect to understanding and tracking network dependencies. And then, as Raleigh mentioned, we'll save a little time at the end for Q&A. So let's jump right in here. I think before we get into the topic, I want to make sure that everyone understands why we're talking about this. And it really ties back to the fact that networks are just so important today in organizations and businesses. They really never have been more important. And essentially, they have to be highly reliable, high-performing infrastructure. Any sort of disruption must be kept to an absolute minimum, and downtime especially kept to as short a time period as possible. So the problem, of course, with doing that is when problems do occur, and they do occur, really you need to figure out very quickly. Those who are responsible for managing and operating the network need to figure out very quickly, is the problem, the source of that problem, is it in the network, number one, and if the answer to that is yes, and it's not always yes. But when it is, where is the problem? Where can I find the source of that problem? And that's exactly what we're going to talk about today in terms of techniques to help with that. The challenge that is left for network managers and operators to grapple with is having the right information for that rapid recognition of problems and really successful conclusion of root cause analysis so that recovery actions can take place. And the answer that EMA has found to be true over the years is to really look beyond simply understanding what makes up the network in terms of devices to understand how the network is actually connected, and that's where we're going to get into this concept of dependencies in the network. So let's do a little bit better job of defining what we mean by network dependency. So remember, everything depends on connectivity. We wouldn't have much of an IT function if not for the network tying together the servers with the end users and the applications to the applications. There's lots of connectivity required. We have IT-based IP communications and unified communications. We have machine-to-machine activity going on. We have user-to-machine activity. We have direct customer commercial models where your customers are coming into your organization through electronic techniques like this. It all depends on networks being up and running. But really, it's a composition of the elements that are the network devices and the connections between those elements, of course, that really make a network out of this whole layer. And so the connectivity is really the important part of this, not just the elements themselves. It has to do with these connectivities and paths. So from a conceptual perspective, when we talk about network dependencies and what we're going to talk about today, we're going to talk about the relationships that we see between the network elements. At its most atomic level, that starts with the relationships between any particular network element or device and everything that it's immediately attached to. When you then connect those up across a chain of such relationships, you'll have a picture of how the entire network infrastructure is related to one another. Not just which devices are there, but exactly how they are connected to each other and how they talk to each other. Now, from a more technical perspective, we can also define network dependencies in another way. And network dependencies, by this definition, is basically what's happening at layer 1 and layer 2 of the OSI model. It's a topological connectivity that occurs down at the most basic connection levels. So before we go any further, I want to take a quick moment to refresh everyone on the OSI model, since I just referred to it, and to illustrate why it's important to understand these concepts as we talk about the various different choices and directions and strategies in the rest of the session here today. So the OSI model is 7 layers. The bottom 3 are really where most of the network management functions take place, where most of the attention is paid by networking folks. Everything 4 through 7 is where the applications live. By the way, lots of interesting things going on up there. Lots of things that network monitoring tools can do up in those layers. But when we're talking about network dependencies, we're really talking about what's happening down in layers 1, 2, and 3. Now, layer 1 is a physical layer. That's the copper wire. It's a fiber. It's a radio frequency for Wi-Fi. That is the actual method of transport and electrical connectivity or radio connectivity or optical connectivity. There's not a lot of information that you can gather from the physical layer. Either it's working or it's not. But when you take one step up to layer 2, there's a lot of information. Layer 2 is the MAC layer. This is where MAC addresses are used, and this is where you find the information about how things are actually connected to one another. The one step up is layer 3. This is the network layer. This is where IP addresses are used. Now, most management tools, all management tools, I will say, that I know of, certainly have plenty of functionality and capability around understanding IP addresses. It tends to be sort of the center of the network management universe, is to operate around IP addresses. Most tools are not designed to specifically work around and show you on a regular basis MAC addresses. That's a layer that's usually hidden because it's more complex. Now, again, topic for another day, when we move from IPv4 to IPv6, those addresses in layer 3 start to look an awful lot like the addresses in layer 2, and so that's going to be some interesting challenges. But for today, we're still dealing with, most folks, the vast majority are still dealing with IPv4, and so operating network management and practices in network management around IP addresses are still the norm. So why now, with those in mind, why do we care about this, and what is it really that's special about the network dependencies in layer 2? I actually have lots of conversations with folks, and it's not unusual for me to hear these kinds of questions. The tools have been put in place to manage the devices and make sure the devices are healthy. So why is it important to understand layer 2, and why isn't layer 3 sufficient? Well, there is some key, very important and essential reasons to why that's the case. So layer 3 with the IP addressing in layer 3 is where you do your subnetting. It's where you organize your network from a high-level address perspective. This is very useful and a very essential practice, but the thing that gets left out of this is you don't actually understand within layer 3 how the devices actually are going to talk to each other, because they are going to use layers 2 and 1 to do that. So as a result, you don't understand paths. Paths are not a part of layer 3. So if you want to understand the paths, which are really part of the connectivity story, you have to go the next layer down. And the reason why this is important is because without that information, you have an incomplete picture from which to draw conclusions about whether or not everything is operating as you expect or not. So a little bit more on that. Why do we care? A little more detail. So here's a guy who's very nervous and very unhappy, and I'm sure he's got an idea of what's going on. So a little bit of an extreme example here from this image, but essentially without those dependency information pieces, you won't be able to tell what endpoints are affected when there's a problem in the network, because you don't know exactly how they're connected. You actually also won't necessarily be able to tell if something that appears to be in a disrupted or down state to the management station is really truly down or just simply not reachable by the management station. And the result of this is it takes longer to figure out where the source of a problem is, which is going to mean your troubleshooting takes longer mean time to restore or repair, and that doesn't help anyone. So, of course, if you want to reach a point of Zen and balance and relaxation, again, a little bit of an extreme example here with the image, but essentially you are in a much better position when you do understand this dependency information, because now you recognize not only the devices, but the path between those devices, any 2 points in the network. This also really helps you understand what you know and what you don't know when it comes to up-down status and reachability of any connected element or device. And this really does also form the basis, which we'll talk a lot more about here, about automating fault isolation root cause analysis using layer 2 as a means for sorting out symptoms versus the root causes. So a little bit of a quick view just to sort of make sure that these concepts are gelled and you know what I'm talking about when I say network dependencies. A little bit of an illustration here. Here's an example, a very, very simple example of a network that's got, for an organization, it's got 3 sites, a green site, an orange site, a blue site connected by a provider cloud. Management system happens to be in the green site, and that's where the point of visibility is for monitoring. If I have a problem, and that problem starts out, and I recognize it first as a whole bunch of elements that are not reachable in the blue site, and I'm only doing layer 3 type management, well, I know that those devices are there because they all have IP addresses, and I know all of a sudden that I cannot reach them because they're not responding to my normal outreach for either SNMP type monitoring traffic or even ping or anything else I try to do. What I don't know is which is at fault. Where's the source of the issue? I just know that there's a lot of things down. Now, in a lot of cases, when we scale this up to a real size of a true operations network, this turns into something known as an alarm storm, where you get a whole bunch of alarms from a whole bunch of devices. You're not sure that they're related because they're all coming from different addresses. So there is some significant problem. You just don't really know what it is, and an alarm storm results. Now, if I layer in the dependency information, this is the connectivity information, this is the path information, and I understand exactly how I am reaching and seeing each piece of managed equipment from my viewpoint in the management tier, I can see that there is a relationship between these various different elements. And that in fact, in reality, I don't know the state of most of the elements that are showing up as not reachable. What I do know is that I have a last good spot, a last good hop in my path to seeing all those devices, and then things go awry. And so that's really where I need to start focusing. This is the concept of alarm, sort of fault isolation, which is a form of root cause analysis. Very closely related to that is the ability to suppress alarms. If I know this is likely going to be my root cause, well, I can now automatically say anything that is related to that device by a network dependency, 1, 2, 3, 4, 5, however many hops down the line, I can suppress that alarm within my management system and say this is symptomatic, this is not a root cause. So this is what we're trying to get to with this concept of network dependencies. So how do we go about finding them? Well, it's sort of a 2-step process we're going to go through in order to identify dependencies and make sure that we understand them and capture them in our management systems. So I've talked about the fact that there's devices and then there's relationships. And we're going to start with devices. You first have to know what the devices are before you can figure out what the relationships between them are, right? So it is stepwise. So the first thing you'll have to do, and sometimes these are done together, so I'm going to talk about them as 2 sort of independent steps, but in many cases, tools will do these, together along the way in parallel. But we're first going to start talking about how we discover the devices that make up the network. We really want to know about all of the network elements out there. And there's different techniques that can be brought to bear here. Certainly there's a fully automated approach to finding these, and this is typically done by just doing a sweep of IP addresses to look at everything that's out there. You can also start, and here's one that sort of does both dependency and device discovery, the seed and crawl technique, where you give the system one IP address to start on and tell it to go ahead and walk through the network using the peering information that's available. We'll talk about that in a minute, to go and find all the other connected devices. Oftentimes this starts with using ping as just trying to find out whether or not there is anything out there to respond on a particular IP address. And then that's followed up with SNMP or WMI to try to figure out what it is that's responding and understand what type of element that is. Big range sweeps can make sense for initial setup, but they can make sense for other reasons too that we're going to talk about. Now, there's a semi-automated approach that you can use, which is to say, I'm not going to do a sweep. I actually want to do a more discrete approach to this, and I have a list of addresses that I want to go discover. So you can load in, most tools will allow you to load in a list of addresses that you then go walk through and look at each device and figure out what it is and how it's configured. Or you can do this on a manual one-by-one basis too, and this is oftentimes done for incremental purposes. Now, what are you trying to figure out when you get there? Well, you need to figure out everything you can about that device. Now, you're usually going to use SNMP, but it could be other interfaces. It could be WMI, especially if it's a Windows-based system. It could be CLI. In growing number of cases, it's now starting to leverage APIs. That's a very early case right now, but that's going to become more popular, I think, down the road. You're basically looking for what is the composition of these devices. What's all the hardware and the software that's inside them? What are the blades? What ports are there? What interfaces are on those ports? What's the configuration settings that have been set up within this device, as well as what are some of the common resources in terms of power and CPU, memory, those sorts of things. And then also, very importantly, you can look and query and find out typically what kinds of policies and services have been configured for each of the interfaces that are set up on the device. Things like VLAN IDs, things like priority marking in diffserv or DSCP. So this is what we want to do from a discovery of device perspective when we have all that information, and this is important because when we move to the next stage, which is understanding and collecting the dependencies, we have to relate that back to which interfaces and even which ports are being used to connect to immediate peer elements and devices and really sort of establish, instantiate those relationships that we're talking about as dependencies. So the next step is to add that dependency information. Once you know what's out there, now you want to know how it's connected. So the typical way to gather this information is to look inside the device and again use SNMP or other techniques to look through and walk through the tables that device maintains. It could be routing tables, could be the ARP cache, it could be bridging tables. Those sorts of sources will tell you what that device thinks it's connected to immediately surrounding it. If you're doing discovery across a routed backbone or routed network, then the routing protocols can help you with this as well. And there's really very commonly these days heavy leverage of things like Cisco Discovery Protocol and Link Layer Discovery Protocol, LLDP, which basically are techniques that the devices will use to figure out for any individual interface what is on the other end of that, the wire connected at that interface or that port. It does broadcasting of here's my address and my MAC address, my IP address and my MAC address. So that gives you the sort of mappings and from which you can construct these dependency maps, these dependency instances. There are, again, sort of an indirect alternative to this. There are some management systems that are starting to harvest and collect this information and make it available via API. This is something you'll run across potentially in the larger organizations where you've got more fully functional element management systems that maintain layer 2 information and can share that back. But again, that's more of a special case than most people will run across. I think it's one that we might see growing over time, so I mention it here. The other is manual. So this does depend on the management tools you're using supporting this. But if the management system has the ability to recognize and instantiate some concept of connectivity, including who is on which end of a link, and then what the path is between there, then you should be able to describe or define these manually if that is your choice. If you either don't have the information from one of the sources I mentioned up above, or you choose not to do this level of depth of discovery when you run discovery type processes, then defining them by the UI and by a per device management interface is oftentimes possible. You'll have to rely on documentation or your own knowledge of the connectivity. You can oftentimes get some of this information by looking in the device configurations themselves, but then you'll have to go and instantiate that on your own. So with that background in terms of what we're talking about with dependencies and and how you get there and what they are and why they're important. Let's shift gears a little and talk about some of the best practices that EMA has seen emerge over the last many years we've been covering this sector. And I want to start out, though, with a little bit of before we get to this best practice, I want to start out with acknowledging a kind of a curious situation that I find really fascinating. So we just produced and published what we call a radar report. It's a landscape review of enterprise network availability monitoring systems, or ENAMs, for our lovely little acronym there. So that's the EMA ENAMs radar report. We just published it in July. And as part of this, we reviewed, I think it was 17 different network management platforms. These are tools that would normally be used by network managers and operators. They are the tools that you would typically see up in a NOC, if you have a NOC. And we looked at each of them and looked at the sort of scope of technical capabilities. We also looked at the total cost of installation, operations, and ownership to try to get an idea of, what's the value for the buck that you get out of each of these different platforms. And we ask a lot of questions about specific feature sets, including a number of questions about a level of understanding of topology and the discovery tools that are used for building that up. And we ask the vendors to tell us about this, and we do our own verification of the feature capabilities, in part by talking to the people who use the products. And so we had over 40 conversations with end users of network management products, and one really interesting thing came out of it this time around, which we focused on much more intently than we have in the past, which was what level of usage are we seeing of automated discovery? And we found only 1 in 4 was really using them with any regularity. Now, this was really a surprising result to us. Because these tools have been around for, I kid you not, decades. I used to work on them many years ago when I worked with Cabletron, and it was a key piece of the functionality back then, and 15, 18 years ago. So this is not anything relatively new that's not being used because it's new, but there were a number of other concerns with them, and so here were some of the key concerns that we heard, some of the themes. So some people were concerned that automated discovery was just introducing unwanted traffic on their network, so too intensive, and so they shy away from doing scans because it just adds load to the network that they don't want to have on there. It's management overhead. Others were concerned that the results that came back from discoveries were just too broad and too full of stuff they didn't care about. And that's a very valid concern. We're going to talk a little bit about how to deal with that in our best practices here. There was definitely some concerns voiced about finding things that were not accurate, incomplete or inaccurate representations of addresses that are found when walking the devices and looking at what they think is out there. And then lastly, there's concern with what I call sort of the house of cards effect, which is I've spent a lot of time building up this beautiful map of my network, and I don't want an auto discovery tool coming in and reconfiguring it automatically because it found something different. So that's probably the most practical concern I can think from just a human nature perspective. If you put so much time and effort into trying to tune your management platform, you don't want it to be changed without your control. So we'll talk about how to avoid that as well. But again, I sort of call that the house of cards approach, because the problem is if you're not using some technique to make sure you know what's out there, well, then what you have is really sort of hollow in the first place. It's really not an accurate representation of what you're managing. All right, so let's talk now about more practical approaches. What should we really try to do and expect out of, in particular, using discovery techniques and automation techniques to find and instantiate network dependencies? So the overriding objectives here are kind of in 2 categories. One is you want an accurate understanding of what's out there. You do want to understand exactly how things are connected, the nature of those connections, whether or not there's any redundancies in the paths. There's a lot of use of redundant paths these days to try to improve resilience of networks. Rarely do you really run across a fully meshed situation in networks, but there's a lot of examples of partial mesh out there, and or at least redundant links in key areas of the network to make sure that you've got some balancing and some graceful degradation in case you have problems. So accuracy is important. You need to understand exactly how everything's connected. My little simple example I gave earlier didn't show any sort of redundancy, but it certainly is a common use today in network architectures. So the other is consistency, and this has to do with keeping up to date with change. And I think the strongest story we're gonna have to talk about here is the fact that discovery tools and the use of automation really is one of your best bets for figuring out how to keep up with the fact that networks are not static. They are dynamic, increasingly so. New devices get added on a regular basis. In big shops where you've got thousands of devices to manage, something is changing every day and even every hour, and sometimes even more frequent than that. So keeping up with that rate of change is something that is a real challenge and has to be dealt with using automation discovery techniques. So the best approach that EMA advocates based on our review of technologies and practices is to make sure you are taking advantage of your discovery tools. And so discovery tools clearly are designed for doing a couple of basic things. Find the devices that are out there. They all do that. Not all of them will do as good of a job of recognizing dependencies and including definition and instantiation of the dependencies between devices as part of the discovery process. Anything that does go to layer 2 has to at least take a stab at doing that. But there are plenty of tools out there that really only stay at layer 3. How often do you use them? Well, this depends a lot on what you like to do and how dynamic your environment is. Some folks use them on a regular timed, sort of scheduled basis where the system will automatically run a scan once a night or once a week, just to try to pick up what's changed. Equally as common and in fact important to have also in hand is the ability to do incremental discoveries on a more narrow basis. And the cases here are when you've got a new device added or a device that has had its configurations changed. An SMP trap should be coming to your management system, or there's a log entry to watch for somewhere that says, this device configuration has changed. At that point, a discovery of that device to recheck and reassess what components it now comprises can be an immensely useful thing to make sure you're keeping up with those sorts of problems or those sorts of changes. You also want to be able to initiate it on an ad hoc manner as an operator when you think you're not looking at a current picture of what a particular part of the network is that you're trying to understand. The ability to run a discovery to double check and make sure you have that information can be immensely valuable. Finally, what should be the result of this? What should you do with the result of discoveries? Well, there's a lot of valuable data that comes out of discoveries. So if this is something that's being done on an incremental basis, certainly discovery is probably one of the most important things to do when you're first standing up a system. You do a broad range discovery, find everything you can, get it under management as quickly as possible in an automated manner. After that, you're usually doing sort of incremental checks. So what you're really looking for after the initial population is for discovery tools to tell you what's changed, give you an alert, let you know that there's a new device that's now showed up or a changed configuration that's showed up. Oftentimes the tools can automatically update your monitoring tools so that you get the new devices under management right away, or you make adjustments to the way that your management system believes and understands the network is connected automatically. We're going to talk about whether or not automatic is the right thing here in a few minutes. But that's kind of at the core, one of the key things that you should be doing with the discovery results is using it either automated or manually to update your monitoring systems to make sure you're managing that which is really out there. And finally, discoveries actually do a great job of producing a list of what's out there, and this can be really handy for managing assets. It can be an adjunct to auditing processes to make sure you understand all of, for instance, all of the access points, wireless access points that are currently active on your network. I wish I had, some pocket change for every time that I hear about cases where folks were still running across rogue access points being set up in their network by someone with, very good, well-meaning intentions to improve network connectivity and Wi-Fi for their little department or their little site. But they're doing it by going to, out to the retail store and buying a wireless router and connecting it in and connecting that way instead of using the dedicated link they're supposed to be using. So these are the useful things that you should be getting out of discovery tools and what they should do for you. Let me say one more word about automation here before we get into some of the recommendations. Automation really is, in my mind, and as something that we all at EMA are very big fans of, it's really important as a technique within management tools and practices to keep up with change. So the important thing here is there's a lot of ways that you can automate this network dependency, discovery, and mapping. So figuring out where the devices are to be managed, figuring out how they connect to each other, finding and instantiating those dependencies, and keeping tables and maps up to date, and groups. Really important to do that. The automation aspect of discovery is really designed to do that for you specifically. The other element, and I just mentioned this, the reason why automation is so important is this steady, continuing growth in the level of change and the rate of change that happens in networks. Now, a lot of folks have I'd say the benefit of core networks being fairly stable, and that's great. Big organizations are changing, of course, much more commonly than smaller organizations. Smaller organizations may enjoy relatively stable networks that aren't going to change a lot. But with the new technologies that are starting to come into play, especially around virtualization of the network and things like software-defined networking, in the next 2 to 3 to 5 years, you'll see a lot of change in the way that networks are being architected and in the way that networks are designed and programmed to respond to application deployments, to changes in usage patterns, to additions of new resources and users. And this is going to, keeping up with the change that's being driven by non-traditional network management and configuration practices, is going to become more and more difficult to do on a manual basis. So the automation of discovery and of keeping you apprised of what's changed is not only important now in some shops, but I think will continue to be increasingly important for organizations of all sizes. All right, so let's talk now finally about what some things are that you should expect. How can we overcome some of those concerns I talked about earlier? What can the management tools do for you, and what should you expect of your management tools? So some things here, I'm going to walk through these one by one. First of all, I would say expect your management tools to give you some choices in the way that you go about discovering. And in particular, things like, are we fully automated or partially automated? What type of protocols are we going to use? Am I going to run this on a regular basis? Am I going to set it up to be triggered? Is it some combination of the above? The more flexibility, the better, because each organization is going to have to deal with specifics about what sorts of rates of change, what sorts of intricacies or details of your network environment you're dealing with. This is important to have a lot of flexibility here. The more, the better. Templates. Now, this is a discovery function. Typically finds things and then brings them to the management system to be dealt with. If you've done a good job of setting up templates for common monitoring profiles, most network management platforms will offer you this capability in some way, certainly for grouping, and also most of them will allow some technique for setting up a standard monitoring template for, let's say, any particular type of work group switch. Or it might be different depending on the brand of switch that you have. So you might want to monitor an Extreme switch differently, or an HP switch differently from a Cisco switch, because in part of the way it's configured and the types of features that it has. But it is a switch, and so there are certain things that you want to do regardless of what brand switch it is. It might also depend on the software version, the software load that's on that device. So you might have certain attributes you want to monitor, or KPIs, key performance indicators, you're going to look at that only make sense once you've upgraded to a certain level of software. So using templates, at least as a basic technique for organizing and making sure you have consistent monitoring for across all common and similar devices and across all devices in general, is a very powerful technique for making sure that you're on top of the state of your network. Another thing you should look for is some flexibility that allows you to have direct control over those results of the discoveries that you get. So something that means you have a method for doing a discovery, but not necessarily automatically acting on the results of the discovery, or only automatically acting on certain aspects of the results. So the more control you have over the entire discovery process, the better. You want it to be automated to find the information, but then not necessarily automated for injecting that information into your management tools. Any changes that happen are made either through a discovery tool or by an operator. You want to make sure there is a means for logging or tracking these kind of actions and results. This is really important for an audit trail. It's really important for stepping back when something goes wrong and you're trying to get back to a good known last state. Really important, especially as you move up the chain towards more and more automation to keep up with change, to be able to go back and look and see what the system did and when and in what sequence. And in fact, it's that sort of logging and tracking, I think, that helps a lot of folks get more comfortable with automatic network management functions, by being able to see in detail exactly what happened and when. Is that the way I expected it to act? Is that the actions I expected to be taken? If no, well then maybe the automation that you're looking at is not the best thing. If yes, well then take advantage of that automation and let the tools do the work for you. And lastly, I have to talk about this too, because this is a growing use case, and I think a really important sort of adjacent point of discussion here, which has to do with the connected endpoints. Now, we've talked about networks and network dependencies mostly so far on a network device to network device basis, but it's also really important to understand the last hop, and that is what is connected to each of those end network devices. In particular, some of the relatively more static pieces of infrastructure that are out there. These would be things like the servers that are dedicated, or servers that are running the hypervisors where you might have virtualized loads. Those servers are going to probably not move around very much. Printers, file servers, some degree of storage. These things that are going to remain relatively physically static are going to show up with a fairly consistent representation at the layer 1 and layer 2 in the stack. And so that's really helpful, even layer 3 usually. So that's really helpful in terms of sort of nailing down as much as you can one end of the sort of end-to-end view that you'll need if you're ever troubleshooting a problem with someone trying to figure out why they can't get to their application of choice, or one of the things they need to do their job. One end of that challenge will be the endpoint that the user is using. That could be a fixed workstation, in which case you might want to include a representation of that in the management system. It might be a mobile platform. It might be a laptop that's going to move around from wireless access point to wireless access point. But on the other end of that channel, that session, that connection, that path, is going to be some relatively fixed server or application that's being hosted on a server. So the more that you expand and start to add, once you have the core network figured out, if you can start adding those relatively fixed endpoints, that increases your understanding and the sort of how quickly you can converge on where a source of a problem might be. So that's important to understand. In fact, I'm finding more and more cases where network managers are responsible for including basic understanding of connectivity of servers and basic health monitoring, right next to the network device monitoring. So this is where discovery can help to some degree to find those for you and put them in your model. Okay, so before we wrap up, I want to move to a couple of sort of helpful hints, things that I've heard in talking to folks both on the vendor and the end user side, the practitioner side. So the first one I'm going to talk about is don't discover as an admin. Now, I've mentioned this in a couple of other ways, so let me explain. One of the ways that you can get around discovery tools that are designed to take automated actions with their results is to run the discovery as a role in your management system that doesn't have write privileges, and I mean that as WRITE privileges. Has read privileges but not write privileges. So Don't set up a special user role that has the ability to go out and do scans or discoveries. The results come back from that, but then since that user doesn't have the rights to to actually take direct actions based on that, all you get is a report and no further actions are taken. This is one way to avoid those automated overwrites if your tool can support this kind of thing. And a lot of them do. I'm continually surprised by how rich and complex now the role-based feature access is in most network management tools. So this could be helpful with one of those concerns, which is ruining my maps. Next, I mentioned this, but I want to reemphasize, it's really important to take the time to leverage the templating and grouping functions in your platform, especially in the way that they're going to help you convert what you find in discovery into instances within the management platform for devices that you're going to manage, and closely related then the dependencies that those devices are going to have to everything else. So if you're taking advantage of templates and groups, you're going to get much further down the path much more quickly. There are a lot of tools that will allow you to use filters to limit the kinds of things that come back from a discovery. So filters can often be set up to look for specific IP address ranges, to not look at certain IP addresses, or more importantly, more commonly, recognize certain types of discovered devices. So if you don't want to discover and include all of your workstations, you set up a filter that filters out the type of sysoid that you get back in the discovery process, which usually will tell you this is a workstation. It doesn't always work that way. You have to be a little creative sometimes depending on what kind of equipment you have. But usually there's some way to uniquely identify the type of element that it is. Is it a network device? Is it an endpoint? If it's an endpoint, is it something you really want to go ahead and put into the management system, or you just want to ignore? So filters in discovery can be extremely powerful and extremely helpful in dealing with one of those other issues that we saw as a concern, which is that it's too broad and returns too much non-important things. And lastly, I think I've beaten this one pretty heavily, but I really think it's important to take advantage of the automation techniques that are available in most tools today. And in particular, look for those features that allow you to do triggered incremental discoveries. So make sure you're taking advantage of event-based discovery or trap-based discovery. They'll have a variety of different names depending on the tool you're using. But something that recognizes especially that a configuration on a device has changed, and use that as a mechanism to trigger a discovery of that device to figure out what's now different, or at least to alert operators that that's something that needs to be done. Okay, so let's just wrap up. I want to give you a few takeaways here before we roll over to Q&A. Couple of things. I think we laid the groundwork here, and I want to reemphasize that network management really is required these days. You've got to keep on top of the networks. They are so important to organizations today, and it's a must-have to have that network be well managed. And by our definition, to do that effectively, you've got to think about not just what makes up the network in terms of the devices, but how that network connects together. And in other words, what are the dependencies? How do they link to one another to create paths and connectivity? Discovery tools, absolutely an indispensable way to keep up with what's going on for both this completeness, consistency, and accuracy of understanding not only what's in the network now, but also what's in the network tomorrow and the next day, as well as how it's all interrelated and how that's changing over time. And then finally, automation. Find ways you can take advantage of automation, in particular keep up with change. I think it's a really key to success. With that, thank you very much. I hope this was helpful. Raleigh, I'd like to flip it back over to you to take any questions that have come in.
Great. Thank you, Jim. Before I jump into the questions, I did want to point people to this additional resource. I will include the URL in the follow-up email that will be sent from Enterprise Management Associates tomorrow. Additionally, it's going to include the on-demand playback as well as that radar report that Jim mentioned, that's a thank you for all of you for taking time out to attend today's event. Also, one more thing, the event will conclude with a 3-question survey. I do encourage you to take that. You will have an option to just request this buyer's guide by simply selecting yes in that survey. So if you could, just take a few moments and take that 3-question survey. All right, Jim, without further ado, I'm going to go ahead and jump right into the questions. The first one is, how high is the risk for doing dependency mapping manually?
That's interesting. So we did have risk in the title. How do you limit risk? And, let me just talk about that for a minute. I think the risk we're talking about here, risk gets used in a number of ways. Risk is often used associated with security, but risk is also operational in nature. So the risks I'm talking about that we're trying to deal with here and improve through our understanding of network dependencies is reduced risk of extended downtime when there's a problem. So I think by not understanding network dependencies, you have huge risk from an operational perspective because you don't understand how things are actually connected and working together when you're trying to figure out how any individual end user or system is trying to talk to another end user or system on the network. It's just that much more difficult to figure that out because you don't understand the paths, you don't understand the connectivity, and therefore you don't understand the dependencies on a step-by-step basis. So the risk really is around not figuring out exactly how things connect. Now, the risk in terms of whether you do this manually versus not manually is really around, I think, accuracy. So we talked about discovery tools being a 2-part in the overall objectives. You want consistency, you want accuracy. If you're doing and instantiating and defining your dependencies on a manual basis, I think it's just really immensely difficult to be, number one, complete and consistent, and number two, to be accurate at all times. So keeping up with that change is really, really hard to do manually, and that's why I'm such a strong advocate for automation in this area.
Great, thank you, Jim. Let's take one more question. It is, how long should discovery processes take?
That's a good question. So discovery processes can take a variable amount of time depending on how much you're trying to discover. So I talked a little bit about sort of incremental discovery, event-based discovery, or maybe operator-initiated discovery. That might only be one or a few devices, and that could be pretty quick. If you're doing a full scan of your network, well, then it really depends on 2 things. Number one, if it is a really big network, it's going to take a while. And number 2, discovery engines, well-designed discovery engines can actually do work in parallel. So they'll have parallel threads going to break up and try to go figure out what's out in various different parts of the network. If you wait for everything to respond on a serial basis and say you've got 1,000 devices, well, it gets to be very long. But if you break it up and parallelize it, you can actually still get through a full scan of a large network in just a matter of a couple of hours.
Excellent. Thank you, Jim. And I wanted to thank our audience once again for joining us. Once again, also be on the lookout for that email from Enterprise Management Associates tomorrow. Enjoy the rest of your day.